Hello. In this video, I am going to be talking about how we find the nth term of quadratic sequences. Okay, so this can be quite tough, and it's definitely something that we need to practice for a while before we absolutely master it. It takes quite a bit of practice to get used to this. Okay, but we have to get through the tricky stage first. We have to find it tough first in order to eventually find it easy. Okay, so let's talk about this sequence on the screen. We've got 4, 7, 12, 19 and 28, and I want to find out the nth term of this sequence. So the first thing I need to do is I need to figure out the difference between the numbers in the sequence. So from 4 to 7, I've got a difference of 3, haven't I? 5, 6, 7. I have a difference of 3. And then from 7 to 12, I have a difference of 5. And then from 12 to 19, I have a difference of 7. And then from 19 to 28, I have a difference of 9. So this is what some people call the first difference. We've got a first difference here, and you can see that the difference isn't consistent. We've got 3, 5, 7, 9. The numbers are increasing by different numbers every time. So we need to find the difference of the difference. In other words, what is the difference between 3 and 5? And the difference between 5 and 7, and the difference between 7 and 9. And we can see that the difference between all of those numbers are the same. It's consistent. The difference between 3 and 5 is 2. The difference between 5 and 7 is 2. And the difference between 7 and 9 is 2. So we now have a consistent common difference in the second difference, okay? So because it was a second difference that's the same, that's how we know it's a quadratic sequence, okay? Now, what we need to do with this difference here, the 2, is we halve it. Whatever the difference is in a quadratic sequence, we need to halve it. So the difference is 2. Half of 2 is 1. And then I'm going to put an n squared after that number 1. Okay, it's just something we do when we are solving quadratic sequences. Okay, we can talk more about the mechanics as the lessons go on, but for now, just put an n squared after the number, after halving the number of the difference. Okay, so the difference was 2, we halved it, we got 1, and then I put an n squared after that. Okay, but 1n is the same as just saying n, isn't it? So I don't need to write 1n. Instead, I'm just going to write n squared. So this is the first part of my sequence. N squared is going to be the first part of my nth term, right? Now what I need to do is I need to write out the sequence of numbers relevant to n squared. So for example, 1 squared and 2 squared and 3 squared. So 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, 4 squared would be 16, 5 squared would be 25. I've written 5 numbers because it corresponds to the 5 numbers of the sequence that we started with. Okay, then I've got to ask myself, how do I get from this number to the first number of the sequence? It's plus 3, isn't it? Okay, so I'm going to write plus 3 underneath. And then the second number, how do I get from 4 to 7? Plus 3. How do I get from 9, the third number, to 12, the third number of the original sequence? Is plus 3. So you can see all of these numbers have a difference. We need to add 3 to all of these numbers to get the original numbers of the sequence. So plus 3, because it's a consistent difference, I'm just going to add that to the first part of the nth term, and now the nth term becomes n squared plus 3. Okay, and we can check to see if we're correct. If we replace n with any number of the sequence, it should mathematically make sense. For example, if I replace n with 1, well, 1 squared is 1, plus 3 is 4. So that makes sense. What about number 2, the second digit? Let's replace n with 2. We should get 7. 2 squared is 4. Plus 3 is 7. So we know that this sequence works, and therefore n squared plus 3 is the nth term of this quadratic sequence. So I'm going to show you another sequence. I'll show you one more time, and then it's your turn to give it a go, okay? So we've got 1, 7, 17, 31, and 49. So first thing I need to do is find the difference between the numbers in the sequence, okay? So what's the difference between 1 and 7? It's 6. What's the difference between 7 and 17? It's 10. What's the difference between 17 and 31? 14. And what's the difference between 31 and 49? 18. So you can see the numbers in this sequence are increasing by different amounts. With the numbers increase by 6, then 10, then 14, then 18, they're different. So what I need to do is find the second difference, okay? So the second difference, the difference between 6 and 10 would be 4. And the difference between 10 and 14 would be 4. And the difference between 14 and 18 would be 4. So now I've got a consistent common difference from my second difference. That means it's a quadratic sequence, okay? Now remember, what we need to do next is we need to halve this second difference. So that becomes 2. Half of 4 is 2. That's going to form the first part of my nth term. And then remember, we always follow it with n squared. So n squared. So that's the first part of my nth term. Now remember what I need to do. I need to write out a sequence of numbers relevant to 2n squared. Okay, so what do I need to do? I need to do 1 squared times 2. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. Okay, we can go up to 5 numbers, but let's just stop there. It doesn't matter too much. So I've got 2, 8, 18, 32. Now what I need to do with this new row of numbers is figure out how I get from each number to the original number, respective number of the sequence. So how do I get from 2 to 1? I subtract 1. How do I get from 8 to 7? I subtract 1. How do I get from 18 to 17? I subtract 1. And you can see it's going to be the same answer for every number of the sequence. And it's a consistent sequence. So we need to add -1 or -1 to our sequence. And our nth term becomes 2n squared, subtract 1. Okay, let's see if this nth term makes sense with our sequence. Okay, let's go for the third number of the sequence. So I'm going to replace n with 3. So 3 squared is 9. 2 9s is 18. Subtract 1 is 17. So the nth term makes sense. We know this is correct. So I've got some questions for you to try now, which are on the screen. So feel free to pause the video and give a go, have a go at solving these questions. This quadratic sequence can get a bit more difficult, which we're going to go through in a second. So once you finish this, play the video, and we're going to talk about a slightly trickier type of quadratic sequence. But we're nearly there. So pause the video, play when you're ready to go on. Okay, so we're now going to look at another sequence. Now you're going to see that this is a little bit trickier than the first sequences we looked at. Not much trickier. As long as we pay close attention, we're going to be okay. All right, so we start off doing the exact same thing we did last time. The difference between the sequence of numbers. So 4 to 9 is 5. 9 to 16 is 7. 16 to 25 is 9. And 25 to 36 is 11. So you can see the difference isn't consistent. Okay, we've got 5 and 7 and 9 and 11. It's going up by a different number each time. So I need to find the second difference. So what's the difference between 5 and 7 and 9 and 9, 11? Well, the difference between them is 2 for this one, 2 for this one, and 2 for this one. Okay, so far so good. So far it's exactly the same as the first questions we looked at. We know it's a quadratic sequence because we've found a common difference when we looked for the second differences, okay? So we need to halve our 2, and that becomes 1n, or just n squared. Now what we need to do, remember, is we need to write our new row of numbers relative to our n squared here, okay? So in other words, 1 squared, 2 squared, 3 squared, 4 squared. So 1 squared would be 1, 2 squared would be 4, 3 squared would be 9, 4 squared would be 16. Let's stop there. Okay, now this is where things are going to get a bit different. So watch closely, okay? The next thing we need to do is find out the difference between our new row of numbers and our original sequence of numbers. So how do I get from 1 to 4? Well, what I need to do is I need to add 3. I'm going to write it over here just so I've got a bit more room. And how do I get from 4 to 9? I need to add 5. How do I get from 9 to 16? I need to add 7. How do I get from 16 to 25? I need to add 9. Okay, so we'll stop there. Now you can see this difference here in the previous questions. When we looked for this difference, it was always the same. In this case, it's not the same. So what I need to do is ignore the rest of the questions. Just focus now on this bit. Let's just focus on that. Okay, this has become a sequence all by itself. I need to find the nth term of this sequence, and the way that I do that is I figure out how much this sequence is increasing by. Okay, so we can see it's going up by 2. So I'm going to write 2n. Then what I need to do is I need to ask myself, what would be the previous number? What would be this number here had this sequence started one number earlier? So we can work backwards. We've got 9, 7, 5, 3, 1. We've got a positive 1, so I must write +1. Okay, and that's our mini nth term for that sequence. I now need to add this part of the nth term to the original part of the nth term over here. So our nth term becomes n squared, and then we need to add this. So n squared plus 2n plus 1. Okay, so let's see if that works. I'm going to replace n with 1, okay, to see if we get the answer 4. So firstly, 1 squared would be 1. Add 2 times 1, so 1 plus 2 will be 3, plus 1 equals 4. Let's just make sure and use a second number in the sequence, so 2. So 2 squared would be 4, plus 2 times 2, so plus 4, so 4 plus 4 is 8, plus 1 equals 9. So I know that the nth term is correct here. N squared plus 2n plus 1 is the nth term of this sequence. Okay, quite tricky, but make sure if you didn't understand that we rewatch this section in particular, because it can be a bit trickier when we need to find the nth term of that mini sequence. Okay, so nearly at the end, we're going to do one more. So we've got a new sequence on the screen. Difference between 0 and 3 is 3. The difference between 3 and 10 is 7. The difference between 10 and 21 is 11. The difference between 21 and 36 is 15. So you can see that our difference isn't consistent. It goes up by a different number each time. So let's find a second difference. 3 to 7, that's increased by 4. 7 to 11, that's increased by 4. 11 to 15, the difference is 4. So remember, at this stage, when we have found that this difference, we know it's a quadratic sequence because it's a second difference in which the difference became consistent. So we've got a difference of 4. Let's halve it like we've done every time so far. That becomes 2, and then we need to add our n squared. Okay, so 2n squared is what we're currently working with. All right, now I need to write a new sequence of numbers with respect to this part of the nth term here, so 2n squared. Okay, so I need to do 1 squared times 2. So 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. I'm just going to do one more, okay? 4 squared is 16 times 2 is 32. So I've got 4 numbers here. I now need to figure out the difference between these new numbers and my original sequence numbers. So to get from 2 to 0, I need to subtract 2. And to get from 8 to 3, I need to subtract 5. And to get from 18 to 10, I need to subtract 8. Let's leave it there because we're running out of room and it doesn't really matter if we carry on. So this sequence isn't consistent. You can see the numbers are decreasing by a different number each time. We've got -2, -5, -8. So we need to find the nth term of this mini sequence here. Okay, so this is our new sequence. Forget the rest of the question. Forget the rest of it. It's not important now. We're just looking at this bit. Okay, so how do we find the mini nth term of this sequence? Well, what is the difference between these numbers? What's the difference between these numbers? We can see that the numbers are getting smaller. They are decreasing by 3. So we will write -3n. And then we must ask ourselves, well, what number would have come here? What number would have come first if the sequence had started one number earlier? Well, we can go backwards, can't we? 8, 5, 2. So we can see if we keep subtracting 3, we're going to get our answer. Sorry, keep adding 3, we get our answer. So -8 add 3 is -5, -5 add 3 is -2, -2 add 3 is 1. It's a positive one, +1. So I'm going to write +1. That bit's important. We landed on a positive one, so we need to write +1. So now we've got our mini nth term of our mini sequence of numbers. Let's add this to the original part of our nth term. So 2n squared subtract 3n plus 1. And that is our nth term. 2n squared subtract 3n plus 1. Now let's make sure it's correct. Let's go for the second number. So let's replace n with 2. So we have 2 squared is 4. 2 times 4 is 8. So we've got 8 here. Subtract 3 times 2. So subtract 6 plus 1. Let's do the maths. 8 subtract 6 is 2 plus 1 equals 3. So the nth term has worked. This is the nth term of this quadratic sequence. Okay, it's very tricky. So make sure you watch this video a couple of times if you need to, or rewind to certain bits. Make sure you give it a go. But what I would definitely recommend is having a go at these next questions. Now, to check to see if you're correct, what you can do is you can do what I did a minute ago and use the nth term use the answer that you get and replace the n with the numbers in the sequence to see if your nth term is correct. Okay, that's the best way to checking to see if you're correct. All right, if it doesn't quite work, then that means a mistake has been made along the way. I hope this has helped. Thank you very much for watching. Bye.